At Pacific Northwest National Laboratory, we're one of 17 Department of Energy national laboratories that are focused on areas of fundamental science, discovery, understanding the universe around us. We're looking at applied solutions to some of the problems facing us in energy, the environment, and national security. We have about 4,400 scientists, engineers, and support professionals who are working in a wide range of disciplines and applying their expertise to a number of problems. We have about $1 billion in total funding, primarily from the Department of Energy, from the Office of Science for Fundamental Discovery Research, from the applied programs in DOE, including work that we're doing for the automotive industry funded by EERE, or the Office of Energy Efficiency and Renewable Energy.
So we work at Pacific Northwest National Lab on a wide range of vehicle technologies. We have efforts in batteries, we have efforts in lightweight materials, advanced lubricants, emissions control. We have a strong catalysis program we use for things like reduced diesel emissions exhaust. We do a lot of work on joining lightweight materials to let vehicle industry use the new alloys that are being developed, actually be able to integrate those into a vehicle.
Currently, we have several problems with the batteries we are using for electrical vehicles. One is that the batteries don't have enough energy to drive long distance per charge.
Our main goal is try to reduce production cost and improve the energy density and also improve the safety of the batteries. For this purpose, we start with a very fundamental study to understand the material properties from atomic scale to large battery. So once we use advanced characterization techniques and also computer simulation to have a better understanding on how battery material work and why the battery fail. Once we develop new materials, we will try to scale up to a practical product which is more acceptable for industry.
We're really trying to pioneer the research in advancing the use of dissimilar materials, whether that be carbon fiber, aluminum, steel. All of these new materials create new challenges in order to implement them, whether that be in joining and forming. So we are trying to come up and develop these innovative technologies within joining and forming, such as friction stir scribe, where we can join carbon fiber to aluminum. This is important to us because being able to implement and advance the use of dissimilar materials will allow us to create these fuel-efficient, energy-efficient vehicles for the future.
In many of our projects, we are striving very hard to develop fundamental properties, fundamental principles, new materials, and new manufacturing processes. But the real goal is to implement them, to be able to commercialize that technology. So we work very strongly towards a path from fundamental discovery to commercialization.
As a research scientist, I work on composite tanks for hydrogen-fueled vehicles. And as part of the vehicle technologies sector relationship manager, I work on helping our research scientists collaborate with other research institutions, with industry partners, to really make sure that the technologies that are developed can have a real impact on the world, that we can get these technologies out into the real world where they're rolling down the road.
One promising new technology is a process called SHAPE, which stands for Shear-Assisted Processing and Extrusion. SHAPE is a solid-state process that utilizes simultaneous rotational and linear shear during extrusion. Using the SHAPE process, we're able to turn powder, flake, and solid billets directly into extruded rods and tubes that have unique mechanical, electrical, and magnetic properties. Enabled by our one-of-a-kind machine, the SHAPE process is being used to extrude a variety of materials such as magnesium, aluminum, steel, magnets, and even semiconductors.
Technologies we develop here for vehicles right now are helping reduce emissions for heavy trucks, reduce weight for a range of consumer and heavy vehicles. And in the future, we're seeing a lot of effort in vehicle electrification, all electric cars. And one area that's very exciting right now is grid integration and connected vehicles, autonomous vehicles, where we're looking at cars not as discrete units on the road, but as part of a system of transportation that's really going to be the revolution in the next 20 years of vehicles.
PNNL just celebrated our 50th anniversary as a national laboratory last year. And when I look ahead, I'm very excited about what the next 50 years will bring for Pacific Northwest National Laboratory.